In this video, we're going to do two proofs. The first one is going to be direct. The second is going to be proof by cases, but you can also do the first by cases if you so chose. So, if m plus n and n plus p are both even, where m, n, and p are integers, then we need to prove that m plus p is even. So, here's what we're saying. We're saying that, okay, m plus n is equal to 2k for some k, and n plus p is equal to 2j for some j. So we want to show that m plus p is even. So let's start with that. Let's take m plus p. Now, this is where you may get confused, because you may think, hold on a second, we should do cases on m, n, and p, so we can say, okay, there's going to be 8 cases. One where m is even and p are odd, one where they're all even, one where they're all odd, and we're going to pick these n's, m, and p and see which to satisfy and show that it holds for all of the cases that matter. So that's a lot of work. Instead, we're going to do some tricks here. So we have m plus n, we have n plus p. So m plus p is going to be equivalent to, okay, we're going to add an n for m, and then we'll subtract it later. So this is still equal to m here. And then we're going to add p and add an n, and then we're going to subtract n again. So this m plus p, m plus n, plus p plus n, minus n, these are equivalent statements. So essentially we're adding 0, but we're doing it in a very special way. So now we can group these things together. Okay. So this is the same thing as saying, okay, m plus n is the same as 2k, p plus n is the same as 2j, and minus n is the same thing as minus 2n. So we can factor out a 2. So this is 2 times k plus j minus n. So we know that m plus p is 2 times something. So this means that m plus p is even. So we're done. That's a nice trick you can do there. You can do the 8 cases, but it's going to take you a lot longer. And it's probably not worth it time-wise on an exam to attempt that. So remember that you can always add 0 to things to keep it equivalent. So in this case, we use the fact that 0 is equal to positive n minus n, and we used it to group things up with m's and p's, which we already know are equal. Okay, that was the first question. Second question, a little bit trickier to figure out what the cases are. So if x and y are real numbers, then the max of x and y plus the minimum of x and y is just equal to x plus y. So we need 2 cases here. We need one where x is greater or equal to y, and we need 2 where x is less than y. So this covers the whole spectrum. So we have x greater than y, x equal to y, and x less than y. So in the first case, what do we know? We know that the min of x and y, well, x is greater or equal to y, so the minimum is going to be y, and the maximum of x and y is going to be x. So of course, if we add these two together, then we're going to get x plus y. Now in the second case here, well, the minimum of x and y, x is always strictly less than y, so it's going to be x here. The max of x and y, well, y is greater than x, so y is going to be the max. And if we add the two together, we're going to get x plus y. So no matter the order of x and y, which one's greater, which one's smaller, if we add the maximum and the minimum together, we're going to get x plus y. So therefore, we have completed the proof. So if you have any other questions, please leave them in the comments below, and I'll answer them the best that I can.